Good afternoon and welcome back to Pattern Catching. I'm your host Matt with Ashemi, and today we're going to be picking up where we left off looking at the boltons package. Specifically, we're going to be looking at how to debug infinite loops in Python with one of my favoriteest hacks ever. So let's take a loop. Here we have a little program I drummed up. It's got an infinite loop in it. Usually when we run into these things, they're a little bit more complicated, but in essence, they're all the same. You run the program, it says it's starting, and then nothing, right? Or it says it does something, and then it gets to some point, and unless you're smart like me, you don't even have this nice ellipsis feedback to let you know that you're stuck, right? It may say downloading, it may say loading, it may say process beginning, but regardless, the log messages stop, the prints stop, and you really don't get much else out of it. So you do probably what I'm about to do here, which is just hit Control-C and interrupt the program and bang your head on the whiteboard or something and try to figure out what the problem is. Now here we actually have a very small program, but the technique to debug an infinite loop, or at least my first technique, beyond looking at the stack trace, for me is almost always the same. I just go import boltons.debugutils, or rather, from boltons.debugutils, import PDB on signal. Now, what is PDB on signal? It's maybe one of the easiest to use boltons in that you just invoke it at the top of your program, anywhere where you know that the code is for sure going to execute. But if we check out the docs, you'll see here that it installs a signal handler for a signal, which defaults to keyboard interrupt, SIGINT, and that launches a PDB breakpoint. Now, PDB, for those who don't know, is Python's built-in debugger, and it is probably the most life-changing thing I've discovered in Python. It's got to be 10 years now, but I still remember the day I found PDB. I've been doing print-based debugging up to that point, and really this changed the game for me. So it's particularly useful in these really complicated programs, because what happens when I want to introspect the state of my program, what got it into that stuck state, right? The easiest way to reproduce it is, instead of writing a test, just run your program till it gets to that point and hit Control-C, like we just did. So let's try it again with the signal handler installed. So here we are, still got our stuck program. If I hit Control-C, well, wouldn't you know it, there's PDB, and here we are. It's like a REPL. You can run Python code in here. It's basically tells you what you need to do. It says use U to find your code and H for help. So basically, if we run H, you get this whole output telling you to do a bunch of different things, but the key commands, in case you're wondering, quick PDB bootcamp here. L shows you the area of code that you're in, like the line and the surrounding lines that are being executed. You can hit U to go up in the stack, which is what that line was recommending we do. And in fact, when you're using it in this way, pressing U once takes you to the line that you were stuck on in your infinite loop. More often than not. Theoretically, you could hit it at some other point and get unlucky and it comes up somewhere else, so maybe you want to do this a couple of times. But basically now if we look here, we'll see that we're in some deep dark function, sleeping for a second and printing our ellipses. So we can see the entire stack with W, and we can exit with Q. So coming back here, we see that in our infinite loop program, we've got some stopping condition that refuses to stop because, say, this global variable should be true. Most programs, it's more complicated than this, but let's go ahead and fix the bug. Run the infinite loop. And would you look at that, it's not even infinite anymore. Having fixed that, we can go back in, remove the signal handling code from boltons, which doesn't do anything unless you press Control-C in that case, so it's nice and side effect free. And then you can just resume with your normal programming schedule, or your regularly scheduled programming. All right, so let's take a quick look, since that's sort of the name of the game with this. If we look at how it's implemented, you'll see that there's not much to it. Basically, PDB on signal is all of maybe 20 lines, imports the PDB module. Python has some interesting signal handling, good but not great. It does give you a signal module, which has nice constants for, the common like POSIX standard signals like sigint. And then, a little bit of effort is taken to preserve the old handler, and we install the new PDB handler, complete with that little micro documentation. Really, that is one of my favorite recent patterns, micro patterns, in writing Python code. When someone is going to see a line because it's in a stack trace, or because somebody's using PDB, just put a little bit of hints or reminders in a comment, because it will carry through the stack trace all the way through to logging system or your perturb developer at the command line. So yeah, that is how to debug an infinite loop in Python using the boltons.debugutils module. Hopefully you enjoyed. If so, you can check out the rest of the pattern catching series. And in any case, like, subscribe. I'll see you next time.